A circuit is set up as shown in the diagram. Assuming the ammeter has negligible resistance, what is the value of resistor R? So firstly, let's find out what's the total resistance in our circuit. So we're going to use V equals IR. So V over I equals R. Now the voltage is 3 and the current is 0.5. So that gives us a resistance of 6 ohms. So the total resistance is equal to 6. So that's going to equal to R plus 1. So we know 6 equals R plus 1. Therefore, 6 minus 1 is 5, so the answer is C. The diagram shows a thermistor connected to a potential divider circuit. The resistance of the thermistor decreases when its temperature rises, and the thermistor is heated. What happens to the reading on the voltmeter? So the reading on the voltmeter V is equal to the resistance of the thermistor over, I'm just going to call this R, plus the thermistor times by the V in the total voltage going in. Now, as this gets smaller, okay, as RT gets smaller, and we know it's getting smaller because it's being heated and the resistance decreases, the voltage across here is going to get smaller, and in fact the voltage across here would get bigger. But it's not going to go down to 0, but it is going to decrease. So therefore the answer is A. The diagram shows part of an electrical circuit. What's the current in the 2 ohm resistor? Now first, let's just have a look at this. We've got 2 different branches, okay, of our electricity going. One's going this way, one's going this way. So we've got 6 amps going in, and then it's going to split off by Kirchhoff's first law. What we want to know is how much is it going to split by. Well, let's just work out what the total resistance of each branch is. So we've got 2 plus 8, which is going to be 10 ohms. We've got 5 plus 5, which is also going to be 10 ohms. So the current is going to split equally here and here. So this is going to be 3 amps, this is going to be 3 amps. Therefore our answer is C. Which 2 resistor combinations have the same resistance between X and Y? So let's have a look at P first. So we've got 1 over 2 plus 1 over 2 which is equal to 1 over the total. 1 over 2 plus 1 over 2 is a half, so that's going to give us 1 over RT. Therefore the total resistance of A is 1 ohm. Okay, Q. We've got 1 over 1 plus 1 over 1 plus 1 over 2 equals 1 over RT. So we've got 2 over 2 plus 2 over 2 plus 1 over 2, which equals 2 plus 2 plus 1 is 5, 5 over 2. That is equal to 1 over RT. Therefore RT is equal to 2 divided by 5, which equals 0.4 ohms. R, this time we've got 1 over 1 plus 1 over 1 is going to give us the resistance here, going across here. So 1 over 1 plus 1 over 1 is 2. 2 over 1. So the real resistance over here is 1 over 2, which is 0.5. So 2 plus 0.5 is 2.5 ohms. Okay, the last one. Well, this is 2 ohms here, and this is 2 ohms here. So we've got 1 over 2 plus 1 over 2 is equal to 1 over RT. So 1 is equal to 1 over RT. So RT is equal to 1, which is the same as P. So P and S are the same, so therefore the answer is B. How much energy is converted in a resistor of 5 ohms carrying a current of 2 amps for 10 seconds? Okay, so let's have a look. What can we work out? Well, voltage is equal to work done over charge, so that might help us possibly. What else could we do? We're given the resistance, we're given the current, so we can work out the voltage. Okay, so by V equals IR, we know I is equal to 2 and the resistance is equal to 5, so that gives us a total of 10 volts. Okay, so we've got V. We want to know the energy, so I'm going to change this formula and make W the subject, so V times Q equals W. Now, it's 2 amps for 10 seconds, so Q is equal to IT. So we've got 2 times by 10, which is 20 coulombs of charge, so that's our Q. So we've got V is equal to 10 times by 20, which is 200 joules, which is answer D. At which point in the circuit is the current the smallest? Well, the conventional current is going to come around here. Some of it's going to go on this way, some of it's going to go on this way. Now, here the current's going to branch off, so A and C are actually on the same branch. So whatever A is and C is, they're going to be the same. So it's not either A or C. Now, the answer is actually going to be D. The reason why, this has got a lower resistance. Now, if you've got a lower resistance, there's the same voltage across here, across this resistor as there is across here. So if you've got a low resistance, your current can actually be higher. So there's going to be more current going on here than there is going to be going on here. So therefore, the answer is going to be D. The potential difference across a 10 ohm resistor is 5 volts. How much charge passes through the 10 ohm resistor in 30 seconds? So we're going to use the formula Q equals IT. We do know the time, but we don't know the current. But we can use V equals IR to find out what the current is. So V over R equals I. So the voltage was 5, so 5 divided by our resistance, which is 10, gives us 0.5 amps. So now we're going to put this all into this equation here. So 0.5 times by our time, which is 30, gives us 15 coulombs, which is B. A lamp rated 6 volts at 2 amps is switched on for 60 seconds. How much energy is used? Okay, well, V equals work done over charge, or the work done per unit charge. So we want to know how much energy is used, so we're going to do V times by Q equals the energy used. But the problem is you don't know what Q is, but Q equals IT. So we've got 2 times by 60, which is 120 coulombs. So now we don't know how much charge is used. So finally, we're going to just put this all in here. Let me put it over here. So we have got 6 volts times by 120. So 6 times 120 is 720 joules, which is answer D. A 12 volt battery is connected across a parallel arrangement of 2 resistors. What is the reading on the ammeter? Well, firstly let's work out what the total voltage of this circuit is. So we'll use 1 over RT is equal to 1 over 3 plus 1 over 6. So we've got 2 over 6 plus 1 over 6 is 3 over 6. So therefore RT is 6 divided by 3, which is 2 ohms. So we want to find out what the reading on the ammeter is. We know the total resistance of the circuit is 2 ohms, so we'll say V equals IR. The voltage was 12 volts. Okay, we're going to divide by R, so divide by 2, which gives us a current of 6 amps, and that is answer D. Two resistors of 6 ohms and 12 ohms are arranged in parallel. A potential difference is connected across the terminals X and Y. The current through the 6 ohm resistor is 4 amps. What's the current through the ammeter? So the first thing we want to do is work out what's the current going through here, then we can use Kirchhoff's law to work out how much current's going through here. So firstly, what's the voltage between here and here, which is going to be the same as the voltage across here and here? Well, V equals IR. So we've got 4 amps times by 6. So 4 times by 6 is 24 volts. That means also across here we've got 24 volts. So the current here, V over R equals I. So we've got 24 divided by 12, which is 2. So here we've got 2 amps. So if we've got 2 going this way and 4 going this way, coming in we must have 2 plus 4, which is 6, which is B.